Welcome back to Elevate Learn. Today, we're diving into one of the most important concepts in modern JavaScript development, modules. Whether you're building a small project or a massive enterprise application, understanding how to use import and export will transform the way you write code. Modules allow you to organize your code into reusable, maintainable pieces. They're the foundation of professional JavaScript development. By the end of this tutorial, you'll know how to structure your code like a pro. A module is simply a JavaScript file that contains reusable code. Think of it as a container that holds related functionality. Before modules existed, developers had to manage code in a single global scope, which led to naming conflicts and messy dependencies. Modules solve this by creating isolated scopes. Each file has its own namespace, so you can have variables and functions with the same name in different files without conflicts. This is crucial for maintaining clean, scalable codebases. Modern JavaScript uses the ES6 module system, which is now the standard across browsers and Node.js environments. Why should you care about modules? First, organization. When your project grows, keeping everything in one file becomes nightmarish. Modules let you group related functionality together. Second, reusability. Write a utility function once, export it, and use it everywhere. Third, maintainability. Smaller, focused files are easier to understand and debug. Fourth, team collaboration. Different developers can work on different modules without stepping on each other's toes. Finally, performance. Bundlers can split your code into chunks, loading only what's needed. Modules are essential for professional JavaScript development. The export keyword is your gateway to sharing code. When you export something, you're saying, hey, other files can use this. You can export almost anything. Variables, functions, classes, even objects. There are two ways to export, named exports and a default export. Named exports let you export multiple things from one file, and you reference them by name when importing. The default export is a special export. You can only have one per module, and it's what gets imported when someone doesn't specify a name. Let's look at some examples on screen. See how we're using the export keyword directly before our declarations? Named exports are incredibly powerful. They let you export multiple values from a single file, and the importing file explicitly requests what it needs. You import named exports using curly braces. If you only need the add function, you write import add. If you need multiple things, you list them. Import, add, multiply. You can also rename them on import using the as keyword, which is useful if there are naming conflicts. Or you can import everything with an asterisk, which gives you a namespace object containing all exports. This approach is cleaner than creating one giant object with everything inside. Default exports are different. Each module can have exactly one default export. It represents the primary thing that module is about. When you import a default export, you don't use curly braces, and you can name it whatever you want. Notice in the example, we export a logger class as default, then import it without braces and call it logger. You could have called it mylogger or anything else. Default exports are perfect for when your module has one main purpose. A file with a single utility function, a component, a class, make it the default export. Keeps your imports clean and intuitive. Here's a pro tip. You can mix named and default exports in the same file. This is actually a common pattern in professional code. Your module might have one main class or function as the default export, but also export some helper utilities as named exports. When you import, you use a combination syntax. Default import without braces, then named imports in braces. This gives you flexibility. Users can import just what they need, whether it's your main export, utilities, or both. It's a powerful way to design modules that are both straightforward to use and packed with functionality. The import statement is how you bring exported code into your file. By default, imports are static and hoisted, meaning they're processed before any other code in your module runs. You can import from relative paths, which are paths relative to your current file. Use // for the current directory, // for the parent directory, and so on. You can also import from npm packages by their package name, or from absolute paths depending on your setup. Notice you can import multiple things on one line. The .js extension is often optional when using bundlers. One important detail: all imports execute first, in order, before your module's other code. This ensures dependencies are loaded before you use them. Beyond standard imports, JavaScript supports dynamic imports using the import function. This is different from the static import statement. Dynamic imports return a promise, which resolves to the module object. Why use this? Code splitting. If you have heavy modules that aren't needed immediately, lazy load them. Imagine a user clicks a button to open an admin panel. Instead of loading that code up front, dynamically import it when needed. This improves initial page load. You can also conditionally load modules based on user role, browser capabilities, or feature flags. Dynamic imports are powerful for performance optimization in large applications. Re-exporting is when you export something you imported from another module. It's simple but powerful. The common use case is barrel files, typically named index.js. Imagine you have a components folder with button, input, modal files. Rather than importing from each file individually, you create an index.js that re-exports everything. Now users can import all components from the folder directly. This pattern cleans up your import statements and makes it easy to reorganize internals without breaking external imports. You can re-export named exports individually, or use the star operator to re-export everything. It's a key pattern for organizing large projects. One pitfall to watch out for: circular dependencies. This happens when module A imports from B and B imports from A. JavaScript can handle some circular dependencies, but they often lead to undefined values or unexpected behavior. The module that loads first might not have fully initialized the module it's trying to import from. How do you avoid this? First, think about your architecture. If two modules need each other, they probably share concerns that should be separated. Extract shared logic into a third module that both import from. Second, use lazy dynamic imports to break the cycle. Load one module after the other instead of both at startup. Modern bundlers like Webpack will warn you about circular dependencies. Pay attention to those warnings. They're telling you to refactor your code structure. Here's something beautiful about modules. Scope. Everything in a module is private by default. Only what you explicitly export is accessible from outside. In this counterexample, the count variable is private. You can't access it directly. You can only interact with it through the exported functions. This is encapsulation. It's a fundamental principle of good design. Private data is protected from accidental modification. You control exactly how other parts of your application interact with your module. If you need to change the implementation later, as long as your exported interface stays the same, everything still works. This is why modules are so powerful. They give you privacy and control. Let's build something real. Here's a user management module. The user's array is private. You can't manipulate it directly. You can only use the exported functions. AddUser creates a new user and returns it. GetUser retrieves a user by ID. GetAllUsers returns a copy of the array to prevent external code from modifying it. This is encapsulation. The internal implementation is hidden. You could change how users are stored, maybe use a database later without breaking code that uses this module. Notice we return a copy with the spread operator, not the original array. This protects our private data. This pattern is used everywhere in professional applications. Now let's talk about designing good modules. First principle: single responsibility. Each module should have one reason to change. Don't mix API calls with UI logic with data storage. Separate them. Your files are easier to test, understand, and modify. Second, use clear, descriptive names. Don't export vague names like handle or process. Use fetch users or validate email. Third, minimize dependencies. If every module imports from every other module, you've created a tangled web. Architect your dependencies thoughtfully. Fourth, let your file structure reflect your code structure. If you have utilities, data models, and components, organize them in folders. Developers should understand your codebase just by looking at the folders. When you build for production, you use bundlers. These tools take all your modules and combine them into optimized files. Webpack is the industry standard. Vite is newer and faster. Bundlers do amazing things. They can combine modules, minify code, and perform tree shaking. Tree shaking is when unused exports are removed, reducing file size. Bundlers also handle transpilation through tools like Babel. ES6 modules work in modern browsers, but for older browser support, Babel converts ES6 to CommonJS or other formats. When you see configuration files like webpack.config.js or .babelorg, these define how your modules are processed. Understanding these tools helps you appreciate why modules are so powerful in production JavaScript. Before ES6 modules, Node.js used CommonJS with require and module.exports. You'll still see this in many projects. While CommonJS works, ES6 modules are the standardized, future-proof approach. They work in browsers and modern Node.js. The syntax is cleaner and more consistent. If you're starting a new project, use ES6 modules. If you're in a Node.js project using CommonJS, you can switch to ES6 by using the .mjs file extension or by adding type module to your package.json. Most modern projects and frameworks, React, Vue, Angular, Express, all support ES6 modules natively or through bundlers. Understanding both is useful for legacy code, but ES6 is what you should focus on learning. Modular code is a tester's dream. Because modules are isolated with clear interfaces, you can test each one independently. You import the function you want to test, write assertions, and verify behavior. Testing frameworks like Jest and Vitest make this seamless. You can also mock dependencies. If a module imports an API service, you can mock that service in tests so you're only testing the module's logic, not the API. This is called unit testing. In the example, we're testing the calculator functions in isolation. Each test is focused on one function. Modular architecture enables this level of precision. Good tests catch bugs early and give you confidence to refactor safely. Modules and testing go hand in hand. Modules are the foundation of modern performance optimization. Code splitting breaks your app into chunks. Instead of one massive bundle, users download only what they need. If you have an admin panel that most users don't access, put it in a separate module and lazy load it with dynamic imports. The user visits your home page. It loads instantly. No unnecessary admin code. Tree shaking automatically removes unused exports when bundling, shrinking your bundle. Tools like Webpack Bundle Analyzer show you what's taking space. You can then refactor to reduce the bloat. Modern frameworks like Next.js and Nuxt handle code splitting automatically. But understanding modules lets you optimize manually when needed. It's the difference between a snappy app and a slow one. When you publish a package to npm, package.json tells consumers where to find your code. The main field points to the CommonJS entry point, the module field to the ES6 version. Modern packages use the exports field for more control. You define different entry points for different import types. Dependencies are listed here too, your package's own imports. When someone npm installs your package, those dependencies install automatically. Version numbers use semantic versioning. The caret means minor versions are okay. Tilde means patch versions. Understanding package.json is essential for both consuming and publishing modules. It's how the ecosystem stays organized. Let me share some pitfalls I've seen developers hit. First, circular dependencies. We covered this, but it's worth repeating. A imports from B imports from A. Solution: extract shared logic. Second, mixing import and require. In Node.js, you might have CommonJS dependencies and want to use ES6 imports. Stick to one consistently within a file. If your whole project uses ES6, convert everything. Third, overexporting. Don't export every variable. Export only the public API. This makes your module's purpose clear. Fourth, unclear responsibilities. A user module shouldn't have UI code. Component shouldn't do API calls. Keep modules focused. These sound obvious, but in large projects, it's easy to let things creep. Regular code reviews help catch these issues. The ecosystem provides excellent tools for managing modules. ESLint with the import plugin catches common mistakes automatically. It warns about missing files, circular dependencies, and messy import order. Import cost shows the bundle size of each import in your editor, eye-opening when you see that a utility library is 50 kilobytes. Check finds and used dependencies. TypeScript adds type safety. Instead of guessing what a module exports, TypeScript shows you the types. This prevents bugs at import time. These tools aren't mandatory, but they're invaluable as projects grow. They catch problems early and enforce consistency across your team. You now understand JavaScript modules. Let's recap. Modules are the foundation of professional JavaScript. Export and import let you organize code across files. Named exports give you flexibility, default exports simplicity. Design focused modules with clear responsibilities. Minimize dependencies. Use bundlers to combine and optimize. Test each module independently. Practice these concepts. Build a project that uses modules. Refactor old code to use modules. The more you practice, the more natural it becomes. Modular code is maintainable, testable, and scalable. It's how professionals build applications. Thanks for learning with Elevate Learn. Subscribe for more JavaScript tutorials, and I'll see you in the next video.